Hey everyone, welcome to the Blaspheming Bite. My name is Atul John. I'm a tech professional working in the Bay Area, and this is my channel for learning algorithms. It's called Blaspheming because I like to swear in between, and I hope you enjoy it. Today we're going to be learning about how to detect a cycle in a graph. Now, what do you mean by a cycle? You start from some vertex, and then you traverse through the graph, go to some paths, go to some fucking direction, like let's say A, B, C, D, and then you finally end up at the same fucking place that you started. Now, you don't want cycles in a graph, so that's why you try to find out if there's a cycle in a graph. Now, one of the reasons why you could use this algorithm is, for example, let's say that in a Linux environment you have some packages that you want to install, and that's got dependencies. And now if you have a package which is dependent on another package which is actually dependent on that package, you have created a fucking deadlock kind of scenario where you don't really have those packages. Another situation where you could have a cycle is, for example, a child and a parent relationship. If a child is a parent and the parent is a child, and you kind of have them both accessing the same resource, then you could kind of have like a deadlock. So it's very important in computer science to have this kind of situation where you have to find cycles in the graph. Now, this is an example where we're going to use the three-state method. I don't know whether it's called the three-state method, but I kind of refer to it as the three-state method, where we have the concept of visited, but we put three states into it. So we have a state before you even start anything. It's called we'll call that state 0, and then if you have started visiting some guy and you visited that guy, you've processed him. Okay, he is not part of any fucking cycle right now. So then, if he's not part of a fucking cycle, then why do you want to keep looking, right? You just forget about him, just let him go. So in that case, we say that we're going to put him as 1. And now if you're still visiting him, then the other state would be -1. Now, I've drawn a small example of a graph here. You can see it's a directed graph. We don't know whether there's a cycle or not in there yet. And we can see that there's a cycle in this scenario, going from 0 to 1 to 2 to 4 to 5 to 0. So we get one cycle, and that's a deadlock there. You've created a deadlock. We don't want fucking deadlocks. We want to be able to. So before we even start processing this shit, imagine that this graph was small. It was a huge graph, and at some very specific point in the path, you find that, oh shit, I'm coming back to where I started from. We don't want that. That's kind of what we're trying to avoid here. Now, let's try to see how we can use this three-state kind of method to find out if there's a graph or not. Now, I will go through some paths that are wrong in order to be able to kind of give an idea of what we're doing. Okay, so how would you represent this graph in an actual program? I'm going to use the adjacency matrix. So, for example, for 0, the adjacency list would be 1 and 3. For 3, there will be nothing. Now, I'm putting this randomly for a reason, because it's going to come up a lot in our data. Now, 3 doesn't have anything, so that's empty. What about 4? 4 has got, I'm going to say 6 and 5. What does 2 have? 2 has got just 4. It's a lonely sucker. Actually, 3 is a lonely sucker. And then 1 has got 3 and 2. Okay. Now, bit by bit, we're going to traverse through this graph, and let's see how things work out. Any preference in the order? No, I'm just going to start with 0. So the minute, and let's have a visited. and this I'm going to put in order just because I'm lazy, I guess. You know what, let's put it in that order. I'm just showing this because it really doesn't matter. Like, you could have the index using this, or you could have a hash map, and these could be your keys. So those don't have to be in order. So this can be in any fucking order that you want. If you are using CPP, you would be using something called the unordered map. So if this has a key and this is a key, it would map to this. There's 3 maps to nothing, you fucker. 4 maps to 6 and 5, 2 maps to 4, 1 maps to 3 and 2. So that's unordered maps. Coming back, the minute you start this algorithm, you can initialize all of the visited as 0. So that's the state where no fucking processing happened. You're still in your shitty state. You don't know whether it's a cycle or not, and you're just confused. So 0, 0, 0, 0. Are we missing any numbers? Yes, we're missing some numbers. What does 5 have? 5's got 0, and 6 is also a lonely sucker. Yep. No. 6 is also a lonely sucker. So we just do nothing there. And what else do we have? We have 5, set 0, and then 6 as 0. Now let's start rolling this shit, right? So we go to 0, and what do? The moment we start processing some motherfucker, what do? We set the visited array to -1. So now 0 is starting. So we put that as -1. The first video, so still learning, guys, still learning. -1. Okay, now the minute you go into that guy, well, what do? You need to go and check all of the neighbors, all of the vertices that it has connections to. And to do that, what do? We go into our unordered map or whatever bullshit that you came up with and go there. So you have 1 and 3. Now what I'm going to do is, let's take 3 first. I'm just going to assume that instead of like that, it was 3 and 1. That's the reason why I'm saying this, because it comes back to the whole having visited it and it's not part of any shitty cycle is a good thing. I say shitty cycle, but it's a good thing because we want to go through that path. We don't want cycles in so it's a good path. It's a good path. I won't say shitty anymore. It's a good path. Let's go to 3. And the minute you go to 3, what do? You have to make it as visited right now. Okay, now we reach 3. Now when we reach 3, what do? We go and check for it and say, oh, but it's a lonely sucker. It doesn't have anybody going anywhere. So what do? We're going to change 3's visited status and make it as 1. So 1 is a place where you go to this path, you've tried going through this path, you didn't find a cycle, so I'm good, I'm positive that there is no cycle in this path. So if you come down me, no cycles. So, and then we come back. So when you set this as 1, it's kind of telling me that, okay, I'm done processing this path. I'm not going to process it going forward. So I can almost say that what has happened is that I've removed 3 from my graph, because every time I go through my adjacency list, I check, is this guy's visited 1? If it is 1, don't do anything, just come back, just forget it, come back. And that's exactly what is going to happen. So when we processed 3 and now we can process 1. So when you process 1, let's go to 1. And what's the first thing you see in the adjacency list? We forgot to do something. We should have done -1 here. Right? Right. So -1, and then we come and check that 3 is in its adjacency list, and then but when we check the visited value for 3, it's 1. So what does that tell us? Don't go through this path. I'm a good path. I'm a good boy. I don't need to be checked again. So what do? We don't check that guy. We say, okay, I've seen this guy before. He's good. He's a good guy. He's a solid guy. Let's go back. So he goes back and he goes to 2. Now what happens with 2? What is 2? 2 has not been discovered yet. So we set this to -1, and then what does 2 have? 2 just has 4, so we set 4 to -1, and then what happens? 4 has 6 and 5, and then we go to 6 and we set that as -1. Does 6 have any people? No, he's also quite lonely. And then what do? We put 6 to 1. Okay, we put 6 as 1, and then we go to so when we put that as 1, we know what it's almost like it's not even in the graph. As far as being a cycle is concerned, it's in the graph, it's not a cycle. It's a good boy. It's a good boy. All these fucking bastards, man. Oh, fucking bastards. So finally we get to the next guy, 5. And 5, when we go visit him for the first time, we say -1, right? What does 5 have? 5 has 0. Okay. And what is 0's visited right now? It's -1. So we've gone through different ways. We've gone through places where we don't have cycles, and we've reached a point where we reached some guy who was already visited, who is still part of the graph or this path that I'm currently taking, and I've reached back there. What does that give us? That means that we have reached a fucking cycle, and that's why we're using these 3 states. That's pretty much it. The whole point of having the positive one is that, hey, you've been through this path and you didn't find a cycle, so scram, mamush, don't come here. You're good. I'm a good path. Just keep me silent here. And then we keep the -1 to make sure that anytime we go back to somebody and then we see that his visit is -1, we know, okay, oh shit, there's a cycle in this graph. I need to get out of here. Thank you. Hey everyone, if you like the video, please make sure to like, subscribe and share. There's also a GoFundMe page where you can go and fund my wife's dental school, and I would like it if you would donate anything. $1 would be fine. Thank you.